Hello, my name is Gonçalo, also known as Crash, and I'm here to tell you what are high and low level programming languages and what their differences are. A low level programming language is a programming language that provides little or no abstraction for a computer's instruction set, architecture commands, or functions in the language map closely to the processor instructions, usually referring to either machine code or assembly language. I'm showing you in this image some examples. At left you have machine code and assembly code, and at top right you have C++, a lot lower level than Python but higher level than the left ones, and at bottom right Python and BASIC, which are a lot higher level. Basically, a high-level language is a programming language designed to simplify computer programming. It is high-level since it is several steps removed from actual code run on a computer's processor. High-level source code contains easy-to-read syntax and is later converted into low-level language, which can be recognized and run by a specific CPU. The word low refers to small or non-existent amount of abstraction between the language itself and machine language. Because of this, low-level languages are sometimes described as being close to hardware, and programs written in low-level languages tend to be relatively non-portable because they tend to adapt specifically to architecture of the machine they are being programmed into, while the higher-level languages can be programmed in higher-level abstraction and compiled later into several machines because, as they were programmed in low-level, they can be adapted to other machines. So, the lower the code is, the more it tends to be adapted to the machine itself, to the machine it was programmed into, and the less portable it tends to be. For example, Java or Python can run almost everywhere. C++ can run in lots of platforms depending on the level of abstraction it uses or if it uses too much specific CPU architecture characteristics, while assembly will only be used on the machine it was designed to. For example, x86 assembly would run only on x86 machines and not Commodore Amiga machines, for example. Python would be the same on different machines, but you can see in this image the difference between x86 assembly and the assembly from Commodore Amiga or the ZX Spectrum machines. A lot different because they are specific to different processors. Assembly or machine code itself are executed directly without the need of any compiler or interpreter. They are very efficient and allow us to control lots of things like memory allocation and are excellent for the creation of operating systems, but at the same time they are harder to use. The lower the level of the computer language, the higher intelligence you need to have to understand it and program on it. Python would be easier to learn for everybody or even BASIC. The lower the level of the programming language, the higher capabilities of abstraction you need to have on your brain to do the abstraction that they aren't doing for you, and that a high-level language like BASIC or Python already do for you, making them easier to understand. Higher-level languages are less efficient and use more memory than lower-level languages, which can convert to machine code without compilers or interpreters and run directly on the processor. At the same time, the lower the level a language is, the harder to read and modify or reverse engineer it is. True machine code is a stream of raw, usually binary data. A programmer coding in machine code usually codes instructions and data in a more readable form, such as decimal, octal, or hexadecimal, which is translated to internal format by a program called a loader or toggle into the computer's memory from a front panel. It was common to send machine code directly to memory through BASIC on old ZX Spectrums, as you can see in this image. I'm showing you an image of a ZX Spectrum BASIC code in which we would insert directly into memory a bunch of machine code values. As you can see, we can't understand what they mean without a lot of training and memorizing because we are seeing numbers and not instructions. It's even harder than assembly, because each one of these numbers can represent a value or an instruction. So we would have to memorize all of those instructions to know if each one of these numbers represents an instruction or a number. So it would be very hard for you to understand this way. Computer machine code is usually a bunch of ones and zeros, the bits, and if you separate those bits in groups of 8 bits, you would have bytes, and you could represent those bytes in decimal or hexadecimal values. And if you represent those on decimal values, you would have values ranging from 0 to 255, and you would have to memorize which of those were instructions or values to be able to understand this. Assembly allows you to understand better machine code because you would see instructions and values in a separate way. On lower level languages, we had to think about things like registers and memory management, but on higher level languages, we don't need to think about that, and we could think about functions, objects, and other abstractions. Each level of language is relative to the programmer. For a Python programmer, C is very low-level language. And for a C programmer, assembly is a low-level language. And for an assembly programmer, C is a higher-level language, although not as high as Python or BASIC. You can see in this example that most used languages are a lot higher level programming, like Python and Java, which is not as high level as Python but easier than C++ anyway. And C++ is only used because it is very, very, very powerful. As you can see in this chart, the higher computer programming languages like Python are more used than lower level ones like C++. C++ is still used because there are things that can only be done with lower level programming languages like C++ or assembly, and not Java and others. So it is still used a lot nowadays. But as companies need more and more computer programmers nowadays, and there are more high IQ programmers than before, the tendency is to have more and more easy to learn computer programming languages than before, so that companies can hire people with less IQ and less mathematical or logical or abstraction capabilities than if they use C++ or assembly. This way they can hire a lot more people, paying less salaries, and the tendency is to have a lot more programmers with lower abstraction capabilities programming in higher level languages like Python, and less programmers programming in C++. So Python is more used nowadays than ever, as it is a lot easier to learn and a lot cheaper to the companies. You can see in this image, in this pyramid, where the high-level languages stand in relation to low-level languages. But remember that here C++ is a lot lower level than Java and others, and a lot harder, although they appear to be at the same level at this pyramid. But as C++ is able to do object-oriented programming, it can be more abstract than Java anyway, because of the way it does object-oriented programming. C++ is perfect in my point of view, very powerful and allowing very high abstraction levels. So there are some confusing things about languages. C++ is a lot lower language than Java, and Java is easier to use and learn, but C++ had some abstraction capabilities built in, and as such, having all the power C had and Java didn't, it is a lower level language than Java, but at the same time, it can be a higher level language than Java, as it is able to use a higher abstraction level. To understand this, you must realize that the word level in this case refers to abstraction level. So although C++ is a lot more powerful and a lot lower level than Java, it can be higher level at the same time, as it is able to do a lot more abstraction than Java in its object-oriented programming. Now, what's this abstraction all about? Imagine that you are coding a racing cars game, like a Formula 1 games. In such a game, the low level would refer to the bits in the memory, and the very high level refers to the cars themselves, their tires, engines, the racing tracks, etc. So in C++, you are able to go into a lot more specific details in the computer's memory than in Java. For example, moving some bits of memory, or to convert an arbitrary integer to a pointer, and then dereference that pointer to access that arbitrary location in the memory later, things so low level that can't be done in Java. Because in C++ you have a lot more power on the machine for which you are programming and things you won't understand, but that I will explain to you in later lessons. But on the other hand, C++ is a C with added object-oriented programming, which I will explain to you on later lessons, and as such, it is capable of very high abstractions in object-oriented programming in such a way that all those cars, tires, engines, race tracks, etc. will be represented in such a way that you almost forget that you were coding into a binary machine, and in a so high level that couldn't ever be done in Java. So C++ is a lot more powerful than Java. It is lower level than Java, but at the same time, it can be a lot more higher level than Java. Think about Java as a language that has removed the low level characteristics of C++, and with that a lot of its power, but at the same time, they also removed a very high level characteristics it has, so Java is an oversimplification of C++. I guess you now have an idea of what high and low level languages are. The closer to human language they are, the higher they are. I mean, the more abstraction they have, the higher they are. The closer to machine code or the less abstractions they have, the lower they are. C++ is lower level than Java, and as such being a lot more powerful, but as it provides more abstractions with its object-oriented programming, it can be higher level also than Java, which is a curious case. That's why I love C++. It can be very high level with object-oriented programming, but at the same time a lot more powerful than higher level languages like Java. But as it is a lot more complicated than Python and other languages, people don't use it nowadays, as it is harder to learn. So as in universities people teach a lot Python and not C++, there are lots and lots and lots of programmers of Python nowadays and less programmers of C++, which is a harder language, although it is a lot more powerful. So there is a tendency of using more Python than C++. But don't forget that C++ is a lot more powerful than Python, Java, and other languages, but is a lot harder to understand. And for example, I'm showing now an algorithm that I've written in C++, which is used to draw my face at the screen with some charts. And you can see with this algorithm how complicated C++ can be and how powerful it can be also, doing a lot of things with a very low amount of code. And you can try hard, but really, really hard to do something as difficult as this in BASIC in Python, and you won't be able to, because BASIC in Python is a lot less powerful and it is so easy to learn that you can't do algorithms this complicated or even more complicated than this with Python and BASIC. And I'm not trying to show you that programming very hard algorithms is good. I'm trying to show you only that C++ can be a lot harder to learn and that can require a lot more abstraction capabilities from its programmers than Python or BASIC. And that's why in some cases there are algorithms so hard to understand for Python programmers. For example, there are algorithms that can't be easily understood people with IQs lower than a certain amount. I can tell you that this algorithm is easy to understand to an experienced C++ programmer, but if you grab some Python programmers that have an IQ lower than a certain amount, they can be watching this for weeks and they won't understand this. They can even be taught how this works and they can tell you, this works like this and like this because someone taught them that, but they won't understand this perfectly in their minds. They can't abstract their minds enough to understand this if they have an IQ lower than a certain amount. But that doesn't stop them from being good programmers in Python, okay? What I'm telling you is that very high level languages are easier to learn and require less intelligence from these programmers, and C++ can have algorithms so complex that they require a certain amount of IQ and intelligence and abstraction capabilities from its programmers in order for them to use it. So the lower level the programming languages are, the higher they are to be understood, to be learned, and that's the reason why nowadays companies are recruiting programmers that program on higher level languages like Python, because there are a lot more of them. It's a lot easier to learn and a lot cheaper for the companies. C++ programmers are only used in certain specific cases, like assembly programmers, like programming operating systems, etc. I hope you like this video. If you like this video, put a like on this video, share it among your friends, subscribe my channel to see my future lessons about how to program from scratch, and see you in my next video. Goodbye.